At the bottom of the ocean, something has been breaking the rules of what's possible for 3.5 billion years. No light, no tools, no precedent. Engineers from Boeing, Bell Labs, and NASA have all independently concluded they cannot replicate what they found there. Every time they look closer, it gets worse. This is what they were looking at. The mantis shrimp throws a punch that accelerates faster than a .22 caliber bullet. The club it strikes with, no thicker than your finger, absorbs that impact without cracking, without deforming, every time. Filmed at 10,000 frames per second, the moment of contact looks almost slow. The club makes contact. The water around it instantly cavitates, boiling from sheer displacement speed. The surface holds. Boeing's Materials Research Division has been studying the internal architecture of that club since 1998. Their published findings describe an architecture they cannot currently manufacture at scale. That was 1998. The shrimp didn't evolve this to impress engineers. It evolved it to survive. That turns out to be a more demanding brief. The club solves a structural problem. Somewhere in the same ocean, a different organism solved an optical one. No factory, no heating process, no tools. The Venus's flower basket sponge constructs fiber optic cables from silica, the same base material as commercial glass. Its cables transmit light around curves without signal loss. Corning's process requires heating silica to 1,800 degrees Celsius. Precision equipment, controlled environments. The sponge operates at 2 degrees, in total darkness, no tools of any kind. Under magnification, a single sponge fiber bends light around a curve. The light follows. It should not be able to do this. In 2005, Bell Labs compared the sponge's light transmission to their best commercial product. The sponge exceeded it. Their conclusion: the biological manufacturing process was not reproducible with existing technology. The sponge didn't reinvent fiber optics. It solved the same problem 300 million years earlier, under conditions that make the entire industrial process look like overcomplicated guesswork. Neither of those produced a physical phenomenon engineers still cannot create intentionally. The pistol shrimp snaps its claw so fast it creates a cavitation bubble that collapses at approximately 8,000 Kelvin, briefly exceeding the surface temperature of the sun for a fraction of a millisecond. It does this to catch food. At high speed, the collapse produces a visible flash of light, sonoluminescence, generated by the mechanical snap of a joint in open saltwater repeatedly, without any degradation in the mechanism producing it. The closest engineered equivalent is inertial confinement, the process underlying thermonuclear weapons research. The shrimp achieves a proportionally similar energy event using only biology. No containment apparatus, no external energy source beyond the movement of its own claw. The plasma is not the point. The prey is. The plasma is a byproduct of an optimized hunting mechanism. We built fusion research programs to study what the shrimp does automatically. The shrimp has been doing this for 50 million years. That's 3 things that shouldn't exist. None of them are the strangest one we found. What finally made a pharmaceutical company spend $40 million and come back empty-handed was a creature that replaced its entire digestive system with something that shouldn't be alive at all. The Riftia tubeworm lives at hydrothermal vents. No sunlight. Hydrogen sulphide concentrations lethal to almost every organism on Earth. It has no mouth, no stomach, no digestive system. It outsourced the entire thing. Where a gut should be, there is an organ called the trophosome. A cross-section shows it clearly. A dense, dark red mass in the space where digestive organs should exist. No intestine, no stomach lining, just 285 billion sulfur-metabolizing bacteria packed into the cavity where a gut was supposed to be. The bacteria run the chemistry. The worm is the building. A pharmaceutical consortium spent $40 million over 20 years attempting to isolate and replicate the core enzyme this system produces. The enzyme is structurally unstable outside the organism's precise pressure and temperature conditions. The only environment where the chemistry functions is the one that would kill every researcher trying to study it. The tubeworm didn't find a workaround for a toxic environment. It made the poison the engine. That is not adaptation. That is a fundamentally different relationship between biology and chemistry than anything that exists at the surface. What happens when that principle scales to something the length of a football pitch, coordinating without a single neuron in charge? The siphonophore is the longest organism ever recorded, up to 45 meters. It is not a single animal. It is a colony of genetically identical units, each performing a specific function: propulsion, digestion, reproduction, defense, with no central nervous system coordinating any of it. Watch one hunt. Dozens of units extend simultaneously in the same direction, a coordinated feeding strike, as though commanded by something that doesn't exist. Nothing is giving the order. NASA's Jet Propulsion Laboratory has studied siphonophore colony coordination as a model for distributed spacecraft systems. Multiple units, no central command, operating under communication delay. The biological architecture, running on pure chemistry, has outperformed the distributed AI coordination models researchers have run against it. The siphonophore solved collective action without hierarchy, without authority, without a single failure point at the center. It has been running this architecture for 700 million years. Every one of those systems is still running right now. Most of them don't have a name yet. Something we built is already on its way down. Less than 20% of the deep ocean floor has been mapped to the resolution required to identify species. Current estimates place uncatalogued deep-sea species between 700,000 and 1 million. The International Seabed Authority has approved mining exploration contracts covering an area larger than India. The contract map and the survey map don't align. Boeing, 26 years on one club. Unsolved. Bell Labs, one fiber cables manufacturing process. Unreplicable. A pharmaceutical consortium. $40 million, 20 years, one enzyme. Empty-handed. That's 3 organisms. The mining contracts cover habitat for an estimated 700,000 more. We are not mining the ocean floor. We are mining a library with no copies, no index, and no recovery mechanism. Every solution in this video took hundreds of millions of years to reach its current form. The structural composite, the optical fiber, the plasma mechanism, the chemical engine, the coordination architecture. All of them are running right now. Most of the organisms carrying them have never been named. The contracts are active. The first collection systems are already on the seafloor. The cobalt in your phone came from somewhere. We don't know yet. What else was there?